Hi there, and welcome to Middle School Math with Dr. K. Today we're going to dive into writing the equation of a line, specifically using the slope-intercept form. Let's jump in. Let's start with an example that will give us a really solid look at a simple linear equation. The problem says Kelsey and Leida are runners. Kelsey is new to running and decides to try and run 5 miles per week. So you can imagine that at week 0 when she starts, Kelsey has not run at all. We'll put a 0 here. After 1 week, she'll have run 5 miles. After 2 weeks, she'll have gone 10 miles altogether. Then at week 3, she'll have run 15. At week 4, she'll have run 20. And at week 5, 25. Leida, it says, has already run 10 miles recently. So at week 0, she's already got 10 miles under her belt. But then she also wants to start running 5 miles per week. So at week 1, she's got 15 miles. At week 2, she's going to have 20 miles, 25, 30, and 35. Now the difference between these two is that Kelsey doesn't start with any miles. So an equation for Kelsey might look like this. The total miles is going to be equal to 5 times the number of weeks. Leida's equation might look a little different. For Leida, the total is going to be equal to 5 times the number of weeks, but she also has that extra 10 miles that she had already run. These two equations are a little bit different, but they're simple examples of what a linear equation could be. In this case, the 5 that you see would be the slope of the line. It's how much each person is increasing per week. They're both adding 5 miles per week. The difference here is that Kelsey starts with 0, but Leida starts with 10, and that's called an intercept. Let's jump into that thought. Now the slope-intercept form of a line looks like this. This is a standard slope-intercept form. Y equals mx plus b. Now y and x are variables, and they represent all of the points that could be on a line. So if you've graphed any lines, if you've found the slope, most lines have lots and lots and lots of points. In fact, they have an infinite number of points because lines go on forever. So y and x are variables that represent those points on that line. M is the variable chosen to represent slope. Now, why does M stand for slope? I don't know. You should Google it. It seems like there's no consensus. But for whatever reason, M is slope. Whatever is increasing each time, whatever the standard increase is, or decrease for that matter, that's your M, that's your slope. And B stands for the y-intercept of a line. Now the question would be, what exactly is an intercept? Every line has 2 intercepts, unless it's horizontal or vertical, and we'll dive into those in another video another time. This line, like many others, has 2 intercepts that you can see on this graph. The first, and the one we use when writing the equation of a line most often, is called the y-intercept. Now the y-intercept is a point, a coordinate point, in this case 0, 8, where the graph crosses the y-axis. Just like the graph has a y-intercept, it also has an x-intercept down here. The x-intercept is essentially the exact opposite. It's a coordinate, in this case 4, 0, and it's where the graph crosses the x-axis. What's interesting about this is in the slope-intercept form, we use the y-intercept and always the y-intercept. You might be wondering, why do we use the y-intercept and why is it represented by a b? I can honestly tell you, I'm not entirely sure, but I like to think of that point as the beginning. If we go back to the example of Leida and Kelsey, Kelsey started by running 0 miles, and then she increased by 5 miles every month. Whereas Leida had already run 10 miles. She began in a different place. For Leida, 10 is her y-intercept. When time was 0, her y was 10. For Kelsey, 0 was the y-intercept. At 0 weeks, she had run 0 miles. That's where she began. Now that we understand that there is this form called slope-intercept form that represents the equation of a line, let's move forward and talk about how to write the equation using that slope-intercept form. So let's start out with the fact that we need y equals mx plus b. As we mentioned earlier, m stands for the slope. That's something we'll need to find and put into this equation. B stands for the y-intercept. Again, something we need to find. Remember, x and y, those are variables. They represent all the points on this line. When we finish our equation, x and y will still be variables. Sometimes we have to plug in a number here and there for x and y, but when we finish the equation of a line, x and y should still be letters. So let's start by finding the slope. Because we have the graph of this line, calculating the slope is relatively easy. Remember, we're going to look for the rise over run, or the change in the y values and the change in the x values. In this case, the rise, the delta y, is 3, and the run, the delta x, is 2. That tells me that my slope is 2 over 3. It's always good to check to make sure that you've got a positive where there should be a positive and a negative where there should be a negative. I notice that this line is increasing and moving towards the top right of my graph. That makes this a positive slope. Now for the y-intercept, I'm just looking for where my line crosses the y-axis. It's important to note that the y-axis is the vertical axis. So all I'm looking for here is this point. That point tells me that this line crosses the y-axis at -3, so my y-intercept is -3. The equation of this line, because I have my slope and my y-intercept, is now relatively easy to write. All I have to do is plug in my slope and plug in my y-intercept. And here I have the slope-intercept form for this line. Let's try another. Again, this time I've given you a couple of points to look at. We're going to try and write the equation of this line using the standard form, y equals mx plus b. Now we call this slope-intercept form for a very specific reason. In this equation, you can find the slope and you can find the y-intercept. There are other ways you can write the equation of a line, but for now, we're just focusing on this one. Again, because I have a graph, I'm going to look for the slope of my line by counting my rise and my run. In this case, my slope increases by 5 with a run of 4, which tells me my slope is 5 over 4. Again, it's pointing toward the top right of my graph, which tells me that it should be a positive slope. My y-intercept, again, is the point where my line crosses the y-axis. The y-axis is here, so my y-intercept in this case is 0. Now what does that look like in an equation? Remember that y and x still have to be letters. The slope we plug in. Here we end up with a plus 0. So in fact, while we could write the equation in this way, we could also just write 5 over 4x. Either of these answers is correct and represents this line. Now this one looks slightly different, but again, we're still trying to write the equation of this line using slope-intercept form. So the first step is always to write out y equals mx plus b. I identify that I'm going to need two things. I'm going to need the slope, and in this case, I can tell my line is different because it's decreasing. It's pointing down to the right instead of up to the right, so I already know my slope will need to be negative. My b value is always the y-intercept. So in finding the slope, I'll draw my lines, I'll look for my rise and my run. I see that it's decreasing by 4, and my run is 6, which tells me that my slope, m, is -4 over 6, which simplifies to -2 over 3. The y-intercept in this case, where it crosses the y-axis, is here at 0, 9. That tells me that it crosses the y-axis at the point 9. When I write my equation, remember, x and y stay variables, and you plug in the slope and the y-intercept. Here are the basic nuts and bolts you need to know for writing the equation of a line using slope-intercept form. First and foremost, you must know y equals mx plus b. It's very commonly used. It's a good thing to have in your memory, memorized, without any extra need for notes and details. M will always stand for the slope, B will always stand for the y-intercept, X and Y will always be written as variables. Like I mentioned before, there will be times where you need to plug something in for X and Y, but we're not to that stage yet. That won't be covered in this video. Once you find the slope and the y-intercept, You can plug them in and you have the equation for a line in slope-intercept form. I hope this helps you understand better how to use slope-intercept form in writing the equation of a line. Thanks for being here, and I'll see you next time.